Hello, good morning, good afternoon, good evening, everyone. Welcome to this month's Connect with Control M. Today, we'll be discussing Control M for Hadoop. My name is Pilar Soria, and I'm a technical support analyst in BNC Software. I have been with BNC for 16 years, and for the last 7 years, I have been supporting the Control M for distributed system products in Europe. I am located in Madrid office, Spain. Today, we are going to cover how to automate Hadoop and Big Data with Control M. Let's start off by looking at the agenda. So we are going to take a quick look to how Control M for Hadoop plugs into your environment, what you need to install, and how to configure Control M for Hadoop. We'll then go through an example of configuration management, connection profiles, and job definitions. During the demo, we'll look at the account and job details and take a look at the information shown in the job output. Before we get any further, I would like to introduce today's panelists, Rick Hansen, Ted Levitt, and James Pendergrass from support, and Musor Natmani from development. I would like to take the opportunity to remind everyone, if they have any questions, please feel free to enter them in the QA panel. If you can put your question to all panelists, we will aim to cover them at the end of the session. Finally, you can save this presentation by going through File and Save. Moving into the product overview, the Control M for Hadoop, that is commonly referred as the CN or plugin, actually connects Control M to the Hadoop framework, which enables the processing of large datasets across Hadoop clusters. With Control M for Hadoop, you can include tasks running in your big data Hadoop cluster from on one central location. Control M for Hadoop supports all Apache Hadoop distribution version 2, and it has to be installed on the Hadoop cluster machine or in the edge node. Since Control M for Hadoop version 8 FISPAC 1, we support secure Hadoop cluster, implementing Kerberos authentication on a Linux 64-bit machine. Now, I'd like to show you what you need to set up Control M for Hadoop in your environment. Going through the implementation steps, Control M for Hadoop must be installed on a Linux on top of Control M agent. The Control M must be the 64-bit version, so you will need to install the plugin on Control M agent version 8. Only one agent is required per Hadoop cluster. We recommend installing Control M for Hadoop FISPAC 1 and the latest patch available. Hadoop is changing very quickly at the moment, so in order to keep up with these changes, we have brought out a number of point patches recently that are not in any of the FISPACs. If you'd like to know more about this patch, please contact BNC customer support. Last but not least, after installing Control M for Hadoop, you must install the Hadoop Forms and the CCN plugins in all EN clients, and also in the Control M EN server. Although we do support all EN versions, we recommend EN version 8, as functionality will be limited on the earliest release. Now, let's see how to configure Control M for Hadoop. From patch 800.103, this is the latest patch, the Control M for Hadoop configuration parameters can be set and managed using a new configuration management utility that is available in the Control M configuration manager. Let's explain what we need to configure Control M for Hadoop. To the left, we have the configuration management window, where we can define Kerberos parameters for a secure cluster environment, and also the full path of the Hadoop streaming jar. The configuration only needs to be done once. This information will be shared for all the accounts. We will explain this during the demo, why we need all these parameters. To the right, we can see the connection profile window, where we can define the accounts that will be used in Hadoop jobs. In authentication section, we can set up the unique user or Kerberos principal that will run the Hadoop jobs. This field is optional. If it is not filled, the job will be submitted with controlling agent user or principal. Now, I would like to explain you what steps you need to follow to configure controlling for Hadoop to authenticate in Kerberos. First, we will need to create the principal. That means adding controlling agent user in Kerberos database. Then we will create the GitHub file that will contain controlling agent principal credentials. If we want to submit jobs with other users, we will need to give privilege to controlling agent principal to impersonate as other principals. For that, we need to add controlling agent principal in key5 login file that will be located in principal's home folder. The last step is to allow controlling agent to impersonate as other principals in Hadoop. We will add in core.site XML file the properties that you can see in the screen. The detailed steps to configure controlling for Hadoop to implement Kerberos authentication are included in controlling for Hadoop release notes. Once the account is created, we can start defining Hadoop jobs. This is a quick look at the Hadoop job details we can see in Workload Automation Client. As you can see, we have 8 job types: grab, MapReduce, streaming, pick, heap, scoop, Hadoop distributed file system file watcher, Tajo, and Hadoop distributed file system commands. We'll be taking a look at this during the demo. So let's go to our demo environment. Okay, let me show you our Hadoop environment. So we are running Cloudera distribution, including Apache Hadoop on a CentOS 64-bit machine. Regarding controlling, we have controlling agent version 8 with controlling for Hadoop version 8 with patch 103. Now, let me show you how to configure controlling for Hadoop with controlling configuration manager. First, we need to check to select configuration management. So, as we said before, in configuration management window, we can set up the Kerberos parameters. Let me remind you, these steps need to be done once, and this only required if we are running Hadoop in secure mode. Maybe you wonder why we need these parameters. I will show you. So, in order to authenticate in Kerberos and get a ticket, we need to run KinitUtility as follows. So, we need to provide the ticket lifetime, the controlling agent's GitHub file, and also the controlling agent principals. Okay, if we enter, we will get a ticket. So, in order to list the ticket, we can run list utility. So, we can see that the principal that have login and get a Kerberos ticket, and when the Kerberos ticket starts and when the Kerberos ticket expires. Okay, let me show you now how to define Hadoop accounts. Let's go back to controlling configuration management and select connection profile management. First, we'll take a look at the non-impersonation account. So as you can see in authentication settings, these two parameters are empty. That means the job will be submitted with controlling agent principal or Unix user if we are not running Hadoop in secure mode. Regarding the other account properties, we will select what Hadoop job types will be submitted with this account. We have pick, scoop, heap, and Tajo job types. So let me show you the scoop properties. So the scoop job will move data from our international DB database to our Hadoop cluster. So for that, we will need to provide the connection parameters. First, we will need to type the username and the password, and then we need to choose the database type. By default, we can select different database types as SQL, MySQL, Oracle, or PostgreSQL. In this case, we only need to type the database host, the database name, and the database port. In case we want to connect to a different database that is not included in this list, we can select other DBDBC complaint database and then provide the Java connection string and the driver class we will need to use to connect to the target database. Similar configuration needs to be done for heap and Tajo programs. Okay, let me show you now the information from impersonation account. With this account, we will submit Hadoop jobs with a different user, with no controlling agent user. So we need to type the user principal and the kita file. Controlling agent will impersonate as user 1 by KeyCU utility. This is a Kerberos utility similar to CU command in Unix. So we will type KeyCU user 1 and controlling agent will impersonate at user 1. We can see here we are any command that will run after KeyCU user 1 will be run with user 1 principal. This is regarding Kerberos, but in order to run Hadoop jobs with other user, we need also to configure Hadoop. So in this case, from the manager, we will select HDFS service and then go to add the following properties in core.size file. Okay, this will allow controlling agent user to run as proxy user. Now let me show you how to define controlling for Hadoop jobs. We have to log in to Workload automation client, and from planning domain, we will select from job palette the Hadoop job type. We will drag and drop this job in our workspace. So I have defined for the demo different job types that I would like to show you. First, we'll take a look to the Java MapReduce type. Okay? So in this case, this job will run as an impersonation account. That means that user 1 will run the Hadoop job. In execution type, we can select the Java MapReduce, and we will need to provide the jar file and main class and the arguments in case it's needed. For this example, we have select the main class P with 2 arguments. Okay, let's go to pick job. Okay, with pick job, this pick job will run with controlling agent principal because I have selected to no-impersonation account. The execution type will be pick, and we need to provide the full path to pick program. In case any argument is needed, any parameters for the pick program, we can add it here in this section. And also, in this case, we have added 2 pre-commands that will run before the pick program is submitted to FS commands that we have in this list. If we want to run any other command that is not included, you can type it. There is no problem. Control for Hadoop will submit this fs command. Okay, let's go and see the properties for scoop import job. This is a scoop job type that will run with user1 principal. And we can see here the scoop command that we will run with this job. In this example, we will read the information from table 1 from MySQL database, and we will import the data in our Hadoop cluster. Finally, after the job completes, we will run this post command in order to list the sample file. Okay? Let's show you the Hadoop remove file. This is a Hadoop distribute file system commands that will only remove the previous file created for scoop job. Okay, and finally, I will show you. This is another example of the scoop job that will only list all the databases that we have in the database. Okay, let's go now to monitoring domain. I would like to show you how the output of the jobs look like and the properties. Okay, so some jobs are running, and at the end we will run this job scoop databases. So let's go first to the MapReduce job. You see the output. Okay, let's go through the output. First, we have information about the account name that will submit the job. Then we can see the job details with the jar program that will this job run. Later, we can see the user, the principal user for this account. And in the job output, we can see first how controlling agent impersonate as user 1, and then the output of this MapReduce job. So this is if we go to the end, we can see the return value of the job and the job statistics. So I would like to show you that in the output we have some information about how the job ran. But if we want to get more details, we can open the job properties and select the job ID. This will open a browser and go to Hadoop in order to show us all the details for this job. Okay, you can see the counter, the map task, and the reduce task. So let's go now to see the output for the big job. This job has run with no impersonation. That means with controlling agent principal. So in the output we don't see any impersonation information. So first, the job ran this pre-command in order to remove a folder from Hadoop. Then we can see the pick command that this job will run, and later the output. If we go to the end, we will see that the job ended. Okay. Okay, we can get more details. We have the succeed and also information about what this pick program ran. We have lot information from input file, and we have import them in our Hadoop. Okay. Now let's see the output of the scoop import job. enter details, we have first information about the scoop command that we will run. As you can see, we have the command and also the connection details to the database. If we move into the sysout, we can see that with this job will run with user 1, principal, and in the job output, as we saw before, we have the impersonation details and the output of the scoop job. We will select information from a sample one table and we will import the data to our Hadoop. At the end, when the job completes, we will run the post command. Okay, let's move on to the last output of the job. Okay, this is a simple Hadoop distributed file system job that will only list the information from a sample. Okay, so now let's run the scoop list database job. In the output of this job, we will see the different databases that we have in our MySQL database server. Okay, similar, the scoop command and the scoop output. Okay, so we have done with the demo. So after the demo, during the demo, I have shown you how to create accounts and how to define jobs from scratch. But what happens if you're already submitting jobs with a different scheduler? While it's preferential to be engaged as early as possible in the Hadoop technology, we realize that this is not always the case. So in case you are using Hadoop OSI scheduling engine, you may like to know with Control-N conversion tool, we have the capability to read the OSI scheduling metadata and build the scheduling definition for you in Control-N. We would like to share with you some information that we think will be useful while implementing Control-N for Hadoop. In KA 425886, you will find what is the latest patch available. Also, we recommend to review Control-N for Hadoop Administrator and the release note of the latest patch before starting to work with Control-N for Hadoop. We also suggest to visit our BNC community site to get connected with other users, view webinars, post questions, and search for answers. BNC Communities is on the bnc.com homepage and can be accessed at communities.bnc.com. Thank you for taking time out your day to attend.